Okay, so now that we know what oxidized means and reduced means, we're going to learn how to solve the problem. So the first step is we split the equation into two equations. We split it into the oxidized equation and then the reduced equation. All right, so to help keep it straight, what I do is I write a little ox and then I write a little red. All right, so we're going to split this up here into two equations, the one that was oxidized and then the one that was reduced. So if we remember back from the first video, we already determined which one was oxidized and which one was reduced. So for the oxidized equation, we just look for the element that was oxidized. And we know it's copper, right? Because copper went from a +1 to a +2. It grew in charge, which means it was oxidized. So we write that right here. Cu plus went to a Cu2 plus. Now we only write these two things because these are the only ones that were oxidized, right? And then in the second part, we write the equation that was reduced. And we know from our last video that chromium was the one that was reduced because it went from a +3 to a +2 charge. And it went down in charge. That means it was reduced. So the first step is you split it into two equations. All right? The second step is you have to balance those equations. So if there was a 2 here, for example, right at the bottom of this, that means we'd have to have a 2 on this side. But thankfully, that's not the case. We look at this and we already see that this is balanced, right? We have 1 copper, 1 copper. That's good. We have 1 chromium, 1 chromium. That's good as well. All right, so we don't have to balance the elements, which is nice. And some problems you will have to do that, so be careful. Our next step is we look at the electrons, okay? So in order for this equation to be balanced, we need the charges on both sides to be the same, all right? So in order to do that, we have to add electrons to the side that is least positive. I know that probably doesn't make a lot of sense right now, but I'll show you it. So first, we look at the charges of both sides. We see, okay, this one has a +2 charge, right? We can tell that because there's only a +2 right here. We look at this charge on the left side, and we see, oh, that's only a +1 charge. The charges are not equal. We have a +2 on this side. We have a +1 on that side. That means we have to add an electron to this side to make it a +1. You always add the electrons to the side that has more charge. All right, so if this was a +3 and this was a +2, you would put an electron on this side. If you're doing it right, you should always have the electrons on the right side for the oxidization equation. And they should always be on the left side for the reduce, as we'll see in just one sec. So we have a +1, we have a +2. How can we make this side be a +1 just like this one? All we do is we add 1 electron. You just put an E and then a little negative sign to know that this is a negative charge. Well, now we have +2 plus a -1 on this side, which equals +1, which is what we want. +1 on this side, +1 on that side. This is good. This is balanced. Now we have to do the second one. If you look, you see that this one has a +3 charge. Sorry, this page is getting pretty messy. This has a +3. We look at this one, we see it has a +2. And we remember our rule, we always add electrons to the side that is more positive, that has more charge. So in order to make this +3